Welcome to the Cloud Containerization presentation. We're going to talk about the cloud. There's many things have been said about the cloud, the driving force behind it. Is that anything out there? Is it internet? Is it computing? Location of resources? For us, is how you do computing. So we're going to take you through in this journey about the containerization with Uniface, so using container technology. Why are we doing this? Because Mike, our product manager, has in the roadmap a plan to have containerization. So we needed to find out how we do that in Uniface. To do this, Alles van Werkel, DevOps engineer, expert in orchestration, containers, Kubernetes, Docker, and myself, Jorge Núñez Orellana, development manager, are going to take you through this journey. We do this also in the memory of Erwin Epson, our friend and colleague, who was the inspiration for us. He left us too early, unfortunately. May he rest in peace. Today's agenda. So we're going to talk with you about the goal we have, then describe how we achieve that goal, that's the target, then glide over the containerization concepts that support that goal, have a live demonstration, and then summarize. To talk about the Uniface containers, we were wondering if we could leverage the state-of-the-art techniques and technologies around containers. We've chosen Docker as containers as just a representation of container technology. For us, it was easy because we have the knowledge in-house and we can do that. So we wanted to see the value. Again, answering the question from Mike. So technology and containers. So we needed to figure out for us how we do infrastructure by code, configuration by code, how we make it portable, would it be scalable, and of course, we're a development lab doing it in small increments. To do that, we've chosen a set of tools that we use in-house, and those are source control and versioning of that, also the artifacts that we produced based on this process. We have pipelines to make sure that we produce those artifacts based on the sources, and adding up to make to the goal of this presentation, containers and orchestration. So let's just move on. What's the target? What are we trying to do? Well, we need to have a business case for this. So you may know the RIAMusicShop application, that web-based application that's been delivered with Uniface for some time and is been updated. Well, we use that. We make sure that we put out there based on containers. We needed to consider that we have a presentation change, so an upgrade of that application, and also do some validation logic, business layer. To take you into that, I'm going to show you what the web architecture of the application is. Well, you know this. We have the backend where the data is located, we have the servers and where Uniface will be installed. We have a web server that's the heart behind it, that's sharing the information, and where we have the HTML, JavaScript, and cascading style sheets, and of course the browsers that access that. In this presentation, we will be focusing on doing the backend part, let's say the Uniface part. You may also want to have a look, if you haven't done that, to the Connect to the Web Community presentation from Jyoti and Herto. They talk all about the web. So how are we going to achieve the target? In this demonstration, we're going to do 4 steps. We have step A, we have the RIAMusicShop that's deployed. We have B, an update, as I told you, HTML and CSS of that application. C, we'll have an update of the Uniface runtime, the execution behind it. And D, will add to that application the business logic. All of this with containers. Again, choosing Docker as a representative of the container technology. How do we do that? Well, going back to that web architecture, that's what we put those things together. We put the 3 containers. One for the database, the data server, one for the Uniface application, and one for the web server, Apache, with all the technologies HTML, JavaScript, and CSS. You may be wondering, what happened here? Why are we doing this? And what is this interesting for you? Well, we're going to dive now into the containerization concepts, and we'll glide through these containerization concepts as Arwin would do that. So the first is a container. Container is designed and built for intermodal use, meaning use across different operating systems as isolated user spaces. So that helps us have a replicable way of executing, and this is containing the libraries, the configurations, and the execution part. We want to clarify that there is a big difference between virtual machines and containers. Virtual machines contain a hypervisor on top of the operating system, the host operating system. There's a hypervisor layer, then a guest operating system, and the application running. In the container technology, we have only the container engine, and those are kernel functions that make use of the existing operating system to run the applications. So you get rid of those hypervisor and guest operating system, making it more thin and lightweight, is what I wanted to say. So looking at how you make those, you make the containers based on the concept of an image. An image is how you assemble that container based on different layers. Of course, at the end, to make it executable, you put on top of that a writable part. We'll see that in more detail. So what we have is a guest operating system, in our case CentOS 7, CentOS 8, just an operating system, and then you start adding layers to build that container image. How do you do that? Well, with a manifest file or a human readable file that we call the Docker file, where you express how those layers are made up. Then once you have the image, you want to run that in containers. To do that, what you have is you use the definition of the image and you execute them. And as I told you before, when you're running an image, you get a writable layer that enables the execution, that has access to the rest of the layers that are available on that image. And that's when you call this is a container being run, the running images. So let's look at how those are for the Uniface that we created. Well, we started having a base operating system, installing the Uniface runtime, and that's what we call the Uniface base image. Then, based on that image, we added an extra layer, and that was the runtime patch, like the ones we deliver every 2 weeks. So we called that the Uniface patch image. And on top of that, another layer, we have the Uniface patch image, the UR. So how does it look like? Well, as you can see, the container image that we created at the end has the 4 layers combined of those 2 images that we used. And now we're just going to execute that, because this makes it that it's identical and it can be replicated everywhere exactly the same. So when we run that container, we only add the read-write layer on top of it, and you have an exact image of what you had to be executed. So going back to what we were doing, this is how it looks like in our web application layer. We had the one for the database that contains different layers, and it also its Docker file, one for Uniface, the one I just showed you with the Uniface UR, and another one for the web server, all of them containing their definitions in Docker files and those manifests. So let's look at how we get those operating. Well, you can run those containers manually by Docker commands so that you enable those images to be a running instance, but you can also do that automatically. And you can also configure that by defining how you want to have those containers executing so that the container engine, once it gets up, has all the nodes available for you. But to do that and to have all that replication in place and that ability to run the containers however you like it, you need another concept. You need to orchestrate those containers, to let them work together. And to work together, we use a tool, and that's Kubernetes. Let's look at the architecture of Kubernetes. Kubernetes is an architecture where you have a controller and he is going to identify the nodes that you are going to be using, and depending on the node you have, it will place the necessary image to be executed. That's already available for you. You just need to pass it on, the information of what you need to be executed at that moment. And that's what we call the desired state. It's also a manifest file that explains or that configures the containers for the Kubernetes environment, and you get everything to be executed. So moving a step ahead, this is what we did. We had our 3 containers, remember those. Now we add a desired state manifest file so that Kubernetes has those 3 for the execution of the application. So we're ready. We have an application that's ready to run. Let's just dive a bit deeper, because in our playbook we needed to do some changes on those containers. So we had to add a new tool. So let's first look at the application. This is the architecture looking from a different angle. We have a database, it's a Postgres database, the Uniface components, the U router and U servers, those are the Uniface version, and we have a Tomcat, which is our web server. In our picture, we added a PC. We're not using that because we're concentrated on the server side, as I told you initially. We had 3 containers, 1 on each of these parts, and to just configure that state, we use a package manager called Helm, and then we gave it a name, and that's what we called versions A, B, C, and D. In this case, you're looking at version A of this Helm version, that's describing that we have 1 container for Postgres, the database, 1 container for the Uniface version, and 1 container in version 1 also for the web server. So that's how we already gave that desired state for Kubernetes, also for the package manager. So let's go back a little bit to see how that would work in Kubernetes. So remember, we had to put that together. Well, first thing we do is we give these 3 containers the desired state, and we have database, web server, and Uniface version. And now we need to change that to update one of those containers. So if we do that, well, how would we do it? Let's take one step back to go to Helm. In the Helm version, I told you it was the description of the containers in a version number. We had just seen version A, and if you look at this picture, we have now version 2 of the application, because that's the only container that we're changing. So the state of that application is that the version 2 of that container, which contains Uniface, is the version B, as we call it, in the package manager. How does that look like when we're executing? Well, the advantage of using orchestration, Kubernetes, and Helm is that we are enabling with containers to have 0 downtimes. So the application is running. Imagine you are buying guitars with the application right now, and we decided to just update the look and feel. Well, it does not stop for you. What we do is, when we ask to deploy version B of the application, the additional container, because Kubernetes identifies already that it has 2 of the 3 composing components already running, so it brings up container 2 that would make the version of Helm, and it waits till the state has been achieved of the executing processes, and all new entries or all new requests are directed to the version B. When that's finished, then Kubernetes naturally terminates the container 1 to give us the desired state of the application B. So at the end, you have in the application what we saw. We have version 1 of the database, version 2 of the Uniface installation, and version 1 of the web server with 0 downtime. That's what we wanted to achieve. So that's what we have with the containerization. We had the 3 containers, database, Uniface version, and web server. And when we orchestrated that, we had a desired state and all running harmonically together. So let's just go and look at that in practice. So we have that in our demo. So in our demo, again, just to remind you what we're doing, we're deploying the RIAMusicShop application. We're doing an update to the presentation layer, to the look and feel, let's say, and then we're updating the business layer of that application. Okay, we're going to look at the live demos as we just explained, and we're going to do that in 4 different steps. We're going to do step A, the application A. We're going to deploy the RIAMusicShop application, deployed. Then B, we're going to update the HTML cascading style sheet. We're going to give it a bit of more flair because it's close to Christmas. Then we're going to do C, because we're going to upgrade the version of Uniface. We're going to bring it more up to date. And D, we're going to do an upgrade of the business logic, updating the application. So let's look at those one by one. So the first step, deploying that RIAMusicShop application. Remember, the Postgres database, the Uniface application, and the Tomcat server. Ala will show that to you now.
Okay, so let's install Uniface in Docker, in Kubernetes. We use Helm for this. Helm is the package manager, as Jorge already said. Helm, we will feed Helm with some predefined values, and this will create a manifest for Kubernetes to get a desired state. So let's do a Helm install. We will install it in the namespace RIAMusicShop. The Helm chart that we use is RIAMusicShop Helm, and the version that we want to install is the chart version 1, and that will install application version A. So here you will see what happens. It says that it will install a RIAMusicShop, that's the Uniface part, and we have a RIAMusicShop Tomcat, and that will install, of course, the application layer in the Tomcat. So let's have a look at the browser. We will open a private screen so that we don't have any cache. And what we will see here is that we have a blue version of the RIAMusicShop installed, and down here in the browser we will see which version of Uniface engine we have running, and that's the March 2019 version. So that's the end of the installation. Let's go back to Jorge.
What you just seen is the RIAMusicShop application where you can order guitars and the full functionality. Database running, Uniface delivering that, and you see that on the web pages. So that was good. Now let's do step 2, the second part. So this is the application what we call B. What we are going to do is upgrade the presentation layer. As I mentioned, we're going to add some Christmas theme to it. And we're doing by installing HTML and cascading style sheets on this one. And as the previous one, Ala will show that to you now.
So let's upgrade the presentation layer to the Christmas theme. So this is step 2, and it will install app version B in this case. So I'll clear my screen and do a Helm upgrade. As you can see, it's the application RIAMusicShop with the Helm chart RIAMusicShop Helm, and the version is 2 in this case, with the same values as we used in the installation. So when upgrading, you will see that it wants to create a new Tomcat container, and when we do a watch on what's happening in Kubernetes, it's that fast, it's already running, and the old Tomcat container has already been terminated. So when we go back, before we had the blue version, so let's start a new private screen to don't have any cookies or cache, and we will see a Christmas theme for the presentation layer. So the Uniface version is still the same, the March 2019 version. We can add something to our cart, proceed to the checkout, press next. And when we don't fill in any details, we will get some red lines. And when we fill in those details, you will see that those will only change when we press next again. So this was the upgrade of the presentation layer. Just to be sure, we have a Helm list RIAMusicShop. And you will see that we have app version B running in Kubernetes. So let's go back to Jorge again.
What you just seen is that Allard just updated one of the containers, the container of the web server, which has the HTML cascading style sheet that makes the application look in a Christmas theme. So that's what we did. The third step, or application C, is when we are going to update the Uniface runtime. That means that the application logic will remain the same, but the Uniface runtime that was executing is going to be upgraded to a more recent version. And we'll do that by changing that middle container. Allard, please take it away.
So let's go to step 3. We have to upgrade the patch version of Uniface now. We can do that also with a Helm upgrade command. So let's do that. And let's change the version to version 3 in this case. Everything will be the same, only the patch version will differ from the version before. When we press enter, we will see what's happening. It will start a new container with a new Uniface version. So when we do a watch on what's happening in the RIAMusicShop, we will see that it's running with a new container for Uniface, and it wants to terminate the old version in this case. As you can see here, during this termination we can already check if the new version is running, because the new version is already active. So let's start a new browser, private browser, and go to the Music Shop. And as you can see here, it's running the October version of Uniface 2020. So let's go back to Jorge again for the latest step.
What we just seen is that without any downtime, Allard was able to upgrade the application, and by looking at the application you saw the version of Uniface that's moved from last year to this year. So the application was changed, the version of it, without zero downtime again. And the last step, step 4, application D, is when we want to make use of that business logic that will be updating the application. So you will see that we can handle better the errors that Allard was showing in the previous one. We can handle it better with the business logic in this one. Again, Allard's turn to show you that.
So let's go to the last step. We've already upgraded the engine version of Uniface, but we also want to have the new features available in our application. Therefore, we need to upgrade the resource or the UR and the JavaScript. So we have those new features available in application version D in our case, and that's chart version 4. Let's go first back to our web interface, where we want to see that the features are not available in the current version, but after upgrading the chart to version 4, application version D, that it will be available. So when we go to the Music Shop, add something to our cart, proceed to the checkout and press next. Without filling in any details, press next again. We will see the red marked fields again. When we add something to those fields, they won't be cleared until we press next again. So we want to have those fields automatically cleared when we add something to the fields. That's the new feature. So Helm list RIAMusicShop will show us that we have application C installed now. So let's upgrade this to version 4. will be installed with the same values as we did before, the same chart, only the version has been changed. As you can see in here, it will change the Uniface container version and the Tomcat application version. As you can see in Kubernetes, it will terminate the Uniface version and the Tomcat version after it runs the new versions of those containers. So as you can see here, everything is running and the old containers are terminating. We can go back to our browser, start a new private screen so that we don't have any cache. And when we started the new RIAMusicShop version, we will add something to our cart. So press next again, and we don't fill in any details when checking out. And as you can see, it will all be marked red because we didn't do what they wanted. So, but when we add something to the fields now, you will see that the fields are automatically being cleared. And be sure that the new feature is available for us. So when we do a Helm list RIAMusicShop again, you will see that the application version is version D now. So the upgrade went fine. So as you can see, we have an upgrade that doesn't have any downtime. So that's what we want for upgrading new applications in the business. So mission accomplished in this case. Let's get back to Jorge for the summary.
What you just saw is that we've updated that container of the application where we have business logic for the handling of those red arrows, the red rectangles around the fields, and the mentioning of the arrows. Again, handling that with the different containers. 4 different applications being managed individually for the pieces that I've made of. So now let's summarize. What we've seen with Uniface is that containers can be used in the application to achieve zero downtime and to upgrade the application in different areas. This again, to answer the questions that we have from product management, how would we do it with the Uniface product? So what we've had is, and what we're looking at is, can we achieve these technological goals that are out there? Yes, of course we can. We can do infrastructure by code. We have been able to show that it's portable because we're using this in the cloud. We show that it's also scalable because this technology applies to containers, Kubernetes, and the Helm. And we, of course, being a development lab, we do this in a small increments so we can validate. Conclusions from us: moving to container technology or the cloud enables you to have a better application, and Uniface can do it for you. Thank you.